Okay, let's do a regression. The dataset that I have up here is regression. The dataset that I have up here is called marketingdata.sav, and in it is just a handful of variables that might be relevant to someone at a marketing agency. And our key criterion variable here, the DV, if you will, is this price variable, right? The first one that's listed here. So let's imagine this is a dataset that was about a bunch of people who tested a new product, a phone maybe, and they asked them, how much would you be willing to pay for this product? And this variable contains everyone's answers. And they also answered questions like, how much do you like the product? That's their opinion, number 2. How much do you know about the company, Google, who produced the product? That's knowledge. And what is your annual household income? That's income. And then gender in there for good measure, but we're not going to use that in the regression today. So we have all these variables, and what we want to do is be able to predict how much people are willing to pay for this phone based on their answers to these other questions. Okay, so we need regression in order to form those opinions. Just as a quick review of correlation, let's go ahead and first test the correlation between your opinion of the product and how much you're willing to pay for it, right? Presumably those are going to be pretty well related. So if we go up to Analyze, down to Correlate, and bivariate. And now I can go ahead and put price and opinion there into the list of variables. Okay, I could put them all in, but let's just go ahead and stick with opinion for now. And that's all I need. So all the defaults are fine on correlation. And if I bring up the output here, we can see that 0.789 is our correlation. I've got some stuff up here from the last one, but go ahead and just pay attention down here. 0.789 is the correlation. That's the R value. And P here is less than 0.001. So we definitely have a significant, strong relationship between opinion and the price that people are willing to pay. Okay, so we know there's a relationship here, which means that if we know someone's opinion, that'll be a pretty strong predictor of how much they're willing to pay. That's where the regression comes in. Okay, so here's how we actually make the regression happen. This is going to give us the information we need to form the regression equation. So let's go up to Analyze here, down to Regression. And there's lots of different forms of regression. I mean, we could go on and on talking about each of them, but we're going to stick with linear. That's definitely the most straightforward. So click on Linear Regression. You can see I already have everything set up here, but let me go ahead and reset this just to walk you through it again. We can take price, put that into the dependent variable slot. That's our criterion here. We're predicting that price. And then down here are our predictor variables. Okay, so for now we're just going to put opinion in there as the lone predictor of how much people are willing to pay. And for now, we'll just go ahead and leave everything just like that. And click OK. That's all we need to do. Set our predictor, set our criterion, and here we get a whole bunch of new information. We really care about this last table, though, the one labeled coefficients. This is the stuff that's going to show us how to make our actual equation. Okay? And what we really are looking for in terms of our A and our B for the regression equation are these first set of numbers under unstandardized coefficients. The B, capital B here is how SPSS labels it. We've got here 56.293 as our constant and 44.841. So what the heck do these mean? These correspond to the A and the B in our regression equation. This first one, what SPSS is calling the constant, is our intercept. Okay, so this means that when opinion is 0, theoretically, people are willing to pay $56.29. Okay, that's what the intercept means. So that's our starting point for the equation. The slope of the line, right, the thing we multiply by someone's opinion, is 44.841. Okay, so this means that for every 1 extra point on the opinion scale, people are willing to pay $45 more for the phone. That's really technically what it means. And as far as we're concerned, this is the important stuff, just these two numbers. So what we would do to write out our equation is to say y, or y hat, if we're talking about the estimate of y, is equal to 56.293 plus 44.841 times x. Okay, so we then use that as our regression equation. And if we want to find out how much are people willing to pay, if their opinion is a 7 on this scale, we would just plug in 7 for X, right? And we would get 56.293 plus 44.841 times 7. One thing I want to point out, though, is that if you look over here to the significance level, we can see that p is equal to 0.001. We don't care so much about that first p-value for the constant. It doesn't really make a lot of sense, but SPSS gives it to us anyway. What we do want to know, though, is this slope significant? And when there's only one variable in your regression, this is exactly the same as the correlation. This significance level is the same as when we tested the correlation. And if you look actually here, the standardized coefficient is 0.789, which you might recognize from the correlation that we just did, right? So the difference between B and beta is that beta is standardized, like a correlation coefficient, right? It puts everything on the same scale, and we can judge stuff from -1 to +1. But for an unstandardized coefficient, this is all still in the units of the variables. Okay, so that's why we keep it like this. And that's all we need to do. That gives us the whole regression equation. Now, to plot out how this actually looks, let's go ahead and make a scatter plot, and we can draw this line right through those points. So let's go up to Graphs, the graphing menu, Chart Builder. And again, I already have this set up, so I'll reset it just to show you from scratch. We go to the scatter/dot option in all of these categories of graphs. Pick just the first one, the simple scatter plot, drag it into the main window, and price will be on the y-axis because that's what we're predicting, and opinion is going to go on the x because that's our predictor. And we click OK. And so we can see now, this, couldn't be clearer. This is definitely a pretty strong correlation. You can see as opinion gets more positive, the price people are willing to pay goes up. Okay, there's a pretty clear pattern here. So this is 550 dots. Each one corresponds to a different person and their specific combination of their price they're willing to pay and the opinion they have of the product. So to draw the line, we can do an easy little trick by double-clicking on the graph, which pulls up the graph editor, the chart editor. And if you look right here, you can see this little option. If you hover over it, it says Add Fit Line at Total. Okay, so don't need to know exactly what that means, but we are fitting the line. We're adding a line of best fit. And if we just click on that, magic happens. There's our line. It draws out the regression line. And even if you look here, you can see this is the equation that we had. Y equals 56 plus 44.84 times X. This is exactly the equation that we just came across. And it draws it out in a nice little swoop through all the data points. On the right here, you can see there's different properties of this line that you can adjust. For our purposes, we're going to keep it at linear. That's really what we care about, just the linear regression, but there are other options if you so desire. And there's also this checkbox here, the attach label to line. If you don't want that equation showing up, you can just uncheck that box, hit apply, and it goes away. Okay, so then you just get a nice clean line there. And to close up shop, you just close this, close the chart editor, and now in the output window, that graph is updated. So now you have the line going through it, and you can right-click and copy it as an image if you want to copy it into your document. And that's all it takes. So you can see here, I went through a lot of different components of this, but it's as simple as throwing in your predictor, throwing in your criterion, and SPSS does all the hard work for you. And from that, you can get your regression equation. So happy predicting and regressing variables on one another. And hopefully this all makes sense for you.